Hi everyone. In this tutorial, in this session, we will try to understand the Blink program that we tested in the last tutorial. With all of you who don't understand anything about Arduino code, let's just try it. So your Arduino Nano is probably blinking like this. I will show you the code. Let me just open this Arduino. Where is it? Okay, this is Blink code. Okay, let me just move this window a little bit to show you all the things in this limited window height. Okay, this is this is the code. The code is like this. The code is in C++ code. The basic grammar for C++ has a lot of sites to refer to on the internet. For example, something like this. Okay, I wrote down some sites in the description below this video. Please refer to it. However, understanding this Blink code here does not require much grammar. So let's just take a look. Here's the slash asterisk sign here, which tells you that when you write it together, everything that follows is command. Every line is command until asterisk slash sign appears again. Comment is just a kind of note. So it's like a memo that the programmer can refer to when he or she reads their code later again. This is not a program code, so I will just skip it. The double slash here also tells us that the entire line is commented. So this line is a kind of note. I will just move on. The code from here is meaningful. Void setup. This void setup tells us this block here is a function with the setup, with the name setup. There's one more function underneath it, void loop. So you can see that this code as a whole consists of two functions called setup and loop. This is the most basic skeleton of Arduino code. To give you a clear view of these skeletons, I will open a new file, new file here. Okay, this opens a new window, new file window. It's an empty file that doesn't write anything yet, but some things already automatically generated here like this. If you look at it, you can see that there are two functions, setup and loop once again. Why do we have two functions, setup and loop, when we open a new file? That's because setup and loop are the essential elements of Arduino code. All Arduino code must have these two functions. If you miss one of them, it will not be compiled at all. The fact that these two things are necessary is understandable if you think about working with microprocessor. When the Arduino is powered up, the whole program automatically starts running from the beginning. Then it will meet this setup function at first stage. Then the function will be executed. The setup function runs only one time. Once it completes, it never runs again. After this setup function, Arduino runs the loop function here. As you can notice from the name loop function, it continues to run repeatedly. Once in, you will never come out again. Arduino does not escape from the loop function unless you cut the power. Through this loop function, Arduino continues to repeat a series of actions which will be written in this block, or wait for a kind of order to arrive from outside. Let's think about the window. Windows 10 or Windows 7 or 8. After the Windows screen turns on, what is the computer doing before you open a program with your mouse click? Windows just waiting until you open a program, just waiting, doing nothing at all. How the very motion of waiting for an event to happen can be coded. Just like Arduino, Windows should be running at the loop waiting for something to happen, right? That is imaginable. So you can probably understand why Arduino needs the setup function that runs only one time when power is applied, and the loop function that doesn't stop once it's started. Now let's go back to the blink function. Blink code here. If you look at the setup function, you can see a function called pin mode. The function called pin mode here is a function that defines the character of digital I/O port. The Arduino Nano has more than 10 digital I/O ports. Each I/O port can be used either as an input port or an output port. The pin mode function decides whether this port is for input or output. LED built-in refers to the port number, and the output tells us the port of this number, LED built-in, is for output. In other words, we decide here to use the port LED built-in as the output port. If you want to use this port as an input port, you can write input here instead of output. Anyway, the point is that we should define the port either for input or for output before we use it. The LED built-in is a predefined function, a predefined constant. The Arduino Nano board has an LED attached on it, and the port it is connected to is LED built-in. In terms of hardware, the LED is attached on port 13, so the LED built-in is actually 13. This means that we are going to use port 13 as the output port. In digital output, you can assign either 1 or 0, 0 or 1. The binary code. You can say this as low or high state. This low or high state corresponds to physically to 0 or 5 volt on the port. Let's move on to the next one, next function here. This is a loop function. There are 4 lines of code here inside. The first function is digital write. This function assigns the high or low values to the specific port. This is a function to assign the high value to LED built-in port. And this is a function to assign the low value on LED built-in port. It is easy to understand from the word digital write. What does it mean to give the Arduino digital port a high value or low value? First of all, high value. That means 5 volt potential is applied on the port. And as I mentioned before, there is an LED on the port. So what will happen to the LED? That's right, the current will flow because 5 volt potential is applied and the light is on. What happens if the digital port is given a low value again, like here? Then the port will be assigned with 0 volt and the LED lights will be off. You turn the light on above here and turn the light off here below. In between, there is a function called delay. It orders delay just as the function name says. For how long? For 1000 milliseconds. So wait for 1 second without doing anything. Turn the lights on, wait a second, turn the lights off, wait a second again. And you are in the loop. So you will go back to the beginning and turn the lights on and turn the lights off. By this process, the lights will keep blinking by the interval of 1 second, right? Now you understand what this code is about. You could understand, and you may not understand. Then please run this video again from the beginning, just like you are in a loop. And enjoy your loop.